Hello, APChem students, and welcome to section 5.5, the collision model. So the learning objective for today is 5.5.a, explain the relationship between the rate of an elementary reaction and the frequency, energy, and orientation of molecular collisions. So let's get into it. So we can examine the probability of whether or not the reaction will occur through a graphical model called the Maxwell-Boltzmann distribution, which should look familiar to you because we already looked at these in Unit 3 when we were talking about gases. So this is what it looks like. So before we were talking about speeds of molecules with Maxwell-Boltzmann distribution based on temperature. Now we're looking at the fraction of molecules having a certain kinetic energy at different temperatures, okay? And so then we can designate the amount of kinetic energy that's necessary for molecules to react at a point on that graph, and then look at the probability of the molecules in the sample to have that energy to undergo the reaction. So it's not letting me click. I hate when this happens. There we go. So the factors that determine this probability are described by the collision theory, which states that in order for a reaction to occur, 1, the molecules must first collide. They have to hit each other. 2, they have to collide in the correct orientation. And 3, with the required amount of energy. So that required amount of energy here is on this Maxwell-Boltzmann distribution. So as a result of these requirements, not all molecular collisions produce a reaction. And so sometimes on the exam, they'll ask you a question and they'll talk about, this is appropriate, why does it not react? And then the collision theory is the reason for that. Sometimes reactions can be favorable in all factors except in terms of their collisions. So let's look at how we can make a reaction more favorable. So here are the conditions in the collision theory. So they typically depend on 3 factors, and we're going to break them down. So the first factor is those numbers of collisions, and we can change those. And these are factors, ways we can impact the rate of reaction. We talked about this back in topic 1. We can change the number of collisions by looking at surface area, pressure, concentration, things like that. So you can do several different things to increase the number of collisions. 2, energy. And we generally impact that with temperature. So if reactants are moving too slowly, then the molecules will bounce off of each other and they won't react. They'll just kind of collide, but then move apart again. So your energy has to be high enough in order for the reaction to occur, and that's called the activation energy. Finally, you need orientation. We can impact this with a catalyst. So a catalyst really helps with the orientation aspect of a reaction. So there are some reactions, notably in biological systems, that are very, very, very difficult to occur just kind of in solution. But if you put a catalyst in there, such as an enzyme, like we would use in biology, then the reaction can occur. And so when the reactants are energetic and oriented correctly, then the chemical reaction will happen. Okay, so let's examine orientation a little bit more closely. So orientation plays an important role in the collision theory. So for example, if we look at this reaction here, and we're going to look at a picture of it, the hydrogen in the HCl molecule must encounter the double bond. So it has to look like this. If it goes in any other direction, the reaction will not occur. The 2 molecules will bounce off of each other. So if the chlorine encounters the double bond, no go. If the chlorine encounters the hydrogens at the end, no go. If the hydrogen encounters the hydrogens at the end, again, no go. It has to be the hydrogen from the hydrochloric acid here that encounters the double bond. If we talk about temperature for a minute, temperature affects the reaction rate in 2 ways. Number 1, it increases the frequency of collisions because it speeds up the molecules. It makes them move faster, and therefore they collide more often. And it gives the molecules more kinetic energy. Again, that faster part, but that's more kinetic energy. So it does those 2 things. More collisions occur, and then more molecules have the threshold energy to perform the reaction. And then again, this is a Maxwell-Boltzmann distribution. Okay, so what should you be able to do with this? Well, number 1, you should be able to use the collision theory to justify if a reaction will proceed given certain conditions. So that's really looking at the Maxwell-Boltzmann distribution, for example. You should also examine Maxwell-Boltzmann distributions to determine how likely a substance is to have a successful collision for the reaction. And so that's doing things like comparing the 2 temperatures and things of that nature. Really what we see a lot with collision theory is particle diagrams, representations, things like that. And then sometimes again being asked like, why might this not occur, even if other factors are favorable for the reaction to happen. And so the collision theory might be the thing that's holding it back. So there you go. So that is the collision theory, and we're going to use the collision theory as a justification for the rest of the unit. So please do make sure that you understand the factors here, and I'll see you again soon for topic 5.6.